Good morning, class. Today we are continuing working with that slope-intercept form, and we are doing CO58. I can determine if the relationship between two variables shows direct variation. Oh boy, that sounds complicated, right? We're going to break it down so we can understand what that means. So we can see from the examples down here, it's in what form? Standard form or slope-intercept form? How do you know it's slope-intercept form, Natalie?
Because it has y equals.
Yeah, starts with that y equals. So we know it's slope-intercept form. Remember that standard form was the ax plus by equals the c. Right, so we know it's slope-intercept form, so we're still using that slope-intercept form. Some lines have what is called direct variation. Below are some examples of equations of lines with direct variation and some without. So let's look at our direct variation lines. Y equals 2x, y equals 2/3 x, y equals negative 4/5 x. Not direct variation. We have y equals negative 3x plus 2, y equals 7/6x minus 3, y equals 8x plus 7. Anybody notice anything? What do you notice, Beckett?
The not variation has a plus or minus number at the end.
What do we call that number at the end? Y equals mx plus b. What is the b?
Y-intercept.
The y-intercept. So these ones that are not a direct variation have a y-intercept listed. These ones do not. So what is the y-intercept for those ones? Amala? 0. That's an important thing to notice. Let's write out our definitions. Direct variation means it is a proportional or direct. We know proportions. We've worked with proportions. Now we're learning that vocab word direct means the same thing. So a proportional or direct relationship from y to x. Now we have a constant of variation. So the constant of variation, you take the y and you divide it by the x. So you make that fraction, y over x. This is also the what? When we have the y over the x. The slope. So that constant of variation is the slope of the line. If it has a direct variation, it's going to have the same slope. Direct variation with a function table means that the direct variation exists when y divided by x is the same. So it is a direct variation when it has the same slope, y over x. So we're writing it out as y divided by x. You can also think of it as that fraction, y over x. That's the slope. Okay? So we're going to determine if each function table below shows a direct variation. If it does, the constant of variation, find the constant of variation and write the equation of the line in slope-intercept form. So let's see how we do that. table. X is 2, 8, 10, and 12. Y is 4, 16, 20, and 24. What do you think we need to do? First thing says determine if there's a direct variation. So that means it's proportionate relationship from Y to X. How do I do that, Fallon?
Divide y by x.
For each set, we need to do Y divided by X, 4 over 2, 16 over 8, 20 over 10, and 24 over 12. Do the math. Simplify it down. Okay? Do 4 divided by 2, 16 divided by 8. What is 4 divided by 2?
2.
What is 16 divided by 8? What's 20 divided by 10?
2.
24 divided by 12.
2.
So if they're all the same, and every single one has to be the same, you will find function tables where only one of them is different. Each and every one has to be the same, and you have to check each and every one. Because you have to know, did we throw one in there that is different? If they are all the same, find the constant of variation. So what is my constant of variation? Look back up. What is the constant of variation? David?
2.
2. Y divided by X. My constant of variation, it is constant. It is always 2. My slope is 2. So I know constant of variation is the slope. Now I can use that to put it into my slope-intercept form. Because that's the second part. Find the constant of variation and write the equation of the line in slope-intercept form. Who can put that into slope-intercept form? Give it a try, Claire.
Y equals 2x.
Ma'am. Because remember that what did we find for that y-intercept? It's always 0. Let's see if that's true. Is it always 0? So let's check it. We're going to take our x and y and our slope, and we're going to check, is that slope-intercept, is the y-intercept actually 0? So y equals mx plus b. 4 equals 2 times 2 is 4 plus b. Subtract the 4, moving it over, and I have 0 equals b. If you want to double check to make sure, this is your checkpoint. Is it really a direct variation? If I put one of those ordered pairs into my slope-intercept form using my slope, I should get 0 for my y-intercept. So that is your checkpoint. Some of us say, I don't want to check my work, I know I'm doing it right. What happens when we don't check our work? Hadley? We can make simple math mistakes. And then you have to redo that objective on the test. Right? Check to make sure that you're not making those simple math mistakes by using your slope, using one of your ordered pairs, and checking to make sure that you get a 0 for your y-intercept. That make sense? On the bottom, it says complete each table given that a direct variation exists. So we know automatically it is proportionate. All of these have a direct variation. Write the line's equation in slope-intercept form. So I'm not checking to see if it's a direct variation. It already is. So how can I fill in? How do I use that knowledge to fill in my table? So I know that my slope is y divided by x, 3 over 1. So I need to put numbers in there that are going to give me that same slope. I have to make sure my y divided by x is going to give me a 3/1. Who can give me an example of what I could put in? Luke.
6/2.
If I do 6/2, so my y is on top, my x is on bottom. You have to make sure y is on top, x on bottom. What would be another example? Robbie? 15/3. Right, is that what you said? 15/3?
I said 15/5.
Oh, thank you. Because your way was right. I just heard you wrong. So if I do 15/5, 15 divided by 5 gets me that 3/1. What's another one I could put, Hadley? 12/4. So my y is 12, my x is 4. They all work. Could you put other ones? Yeah. On the test, I'm going to be looking to see if I divide out each y divided by x, do I get that same slope? You get to choose which y and x you put, as long as we get the exact same slope when we simplify down. Does that make sense? Be careful when there's negatives thrown in, okay? Always simplify that slope down to know if it's a negative or a positive slope. Make sure your x's and y's give us that same negative or positive when we divide them down. Okay? Any questions on today's assignment? Eleanor,
What if we're dividing out with a fraction?
what do you mean?
So, for the next one I did on the calculator 45 3, and I got like -1, so I think we can.
Right, so when we work with slopes, do we work with decimals or do we work with fractions? So,
Oh yeah, so
your fraction is -4/3. Each one of these has to simplify down to 4/3. Okay, that's why I don't deal with decimals. That puts in an extra step that gets confusing. Work with the fractions, it's a whole lot easier. Okay. Any other questions? All right, go ahead and get to work. Remember, when you're done, math packets, Khan Academy. Khan is due tomorrow. Use this time to be looking at those assignments that you haven't started yet to see if you have questions. If you are watching at home, I hope you are well, and I hope to see you soon. Have a wonderful day.